Assalamu alaikum, this is Farisa Khan. So today I am going to present on the topic that is artificial neural network. Deep learning, neural network and artificial neural networks are the talk of the town nowadays. We can see in this slide about the neural networks. Overall, the artificial neural network have been applied to problems ranging from speech recognition to the prediction of protein secondary structure, classification of cancers, and gene prediction. How do they work and what might they be good for? Let's discuss over here about the artificial neural network. Moving to the next slide. These are today's agenda of artificial neural networks. In this presentation, I will define all the topics about the artificial neural networks, a brief history, then the biological concept of neurons and the difference between the artificial neural network and the biological neural network. Afterwards, we will go through with the model of the artificial neural network, how they modeled, and then network topologies. We will also discuss about the activation functions and how it works. Then it comes the perceptrons, and it is very most important topic in artificial neural network. Further, we will discuss about their advantages, disadvantages, and furthermore, here are the layers of artificial neural networks. And the main topic, which indicates, which perform the works overall about the artificial neural network, that is the activation functions. We will go through a brief discussion over on the activation functions. Then we will go through for the representation powers about the AN, then artificial networks, then learning rules are there. At the end, we will go through for the training of AN. So let's move forward, starting from what actually the ANN is. An artificial neural network is a computational model consisting of several processing elements that receives inputs and deliver outputs based on predefined activation functions. There are the number of the activation functions that we need to compile in this overall network system. As artificial neural network, or we can also say this is the simulated neural network, are a subsets of machine learning. They are the sub branch of the machine learning and are at the heart of the deep learning algorithms. Their name and the structure are inspired by the human brain, basically. So we can say these are the analogy of the biological neurons and towards the neural networks, and this is mimicking the way the biological neurons signals to the another. Let's move forward. Now here comes the model of artificial neural networks. You can see over here at the left side, there are the number of the inputs given over here, that is starts from the x1, x2, x3 and so on up to the xm. These are the basically inputs which we have to give the machine, and at the end we are receiving a predict output that is denoted by the y. So W represents over here the weight, and they are the corresponding weight of each input. With the help of these weight, how much that input is important, we are going to next step is the summation of input and the weight. After summation of the input and the weight, we are here to get the output, and that is denoted at the y in. And after y in, the main function comes over here. What kind of function and performance are there? They are basically thresholds, and that is said to be the activation functions, and we will go through and predict some output that is denoted by y. At the right side, a general model of artificial neural network, that net input is given. How we will calculate the net input? Basically, it is very much simple, that we are going to multiply the input and the weight. Afterwards, we have to add all over the inputs and the weight, and this is in net input, and summation of the input and the weight is said to be the net input. what is the output overall. So mathematically output is just the activation function is multiplied to the net input, which we have discussed over here. So output is equals to function can be any type of activation function. We will go through in detail in our next slides. There are the number of the types of the activation functions, ReLU activation functions, and the sigmoid. Different types are there. So that's the model of artificial neural network. Moving forward, now we will discuss here the artificial neural network versus biological neural network. Basically, they are similar. We are taking the concept of our biological neurons, how they works, a human body system works. So symbolically, you can say the inputs and the outputs are very important in this way. So dendrites are basically inputs. So you can see over here dendrites, axons are the outputs, and cell bodies are the activation functions. So soma is said to be the node in artificial neural network. Dendrites are inputs, synapses are the weights or interconnection between the weights, then axons are the output. So this is overall the versus between the ANN and BNN. Inputs are in the numerous and number of the inputs are given. BIOS is very important term we will discuss over here. Then summation of input and the weights. Afterwards the activation function. Then we will predict some kind of output at the end. So I'm going to move forward to the next slide. Then ANN versus BNN. Some other analogies of biological neural networks and the artificial neural networks. In the ANN, silicon transistors are there and they are said to be biological neurons basically in BNN. So billion bytes RAMs are used in the ANN and 200 million neurons are used in human body and biological networks. So these are the differences. Programming capability is in our artificial neural network. Learning capability is in our biological neural networks. The energy consumption is 6 10 raised to power 6 raised to power minus 10 in our biological neural network. In our artificial neural network, 10 raised to power minus 16 is there. So you can see the difference by this table about the artificial neural network and the biological neural network. Moving forward, more detail about their uh, differences with respect to some parameters. Some criteria are over here. According to the processing, the massively parallel, slow but superior than ANN. So in biological, it is very much slow, and we can say in artificial it is most faster as compared to BNN. According to the size, we can see there are the 10 raised to power 11 neurons and 10 raised to power 15 interconnections in BNN. 10 raised to power 2 to 10 raised to power 4 nodes are there in our ANN, artificial neural networks. Mainly depends on the type of application we are going to design. So learning, in the learning parameter, they can tolerate very precious structure and formatted data is required to tolerate different kinds of learning phases in artificial neural network. Then here are storage capacity, stores the information in the synapses, stores the information in continuous memory locations in our artificial neural network. These are overall more details about the difference between our biological system and neural network in a human being and artificial neural network that is made by a human, that is the machine learning. Moving forward, how actually the artificial neural network works. The basic concept I have already discussed over here. It is the analogy of human body or human systems, which has the neurons work over which transmits from inputs to the output, from you can say dendrites to the axons. Synapses are over there. Then we are using the cell bodies the activation functions. Now, at the left side, if you are going to take same concept from the biological concept, that we are doing are showing the input x1 represents the input x2 and so on. These are the xn. These are the inputs we are giving to some system, and according to their corresponding weights, they have own weights given. Weights are basically the information or how much important that input is to be predicted. So the processing element, that is the summation of both input and the weight, and the same thing I have already discussed, that is the function, that is a transfer function, or you can say activation function, which parameter is used as a threshold, and afterward at the end we are getting some outputs at the right side. So this is overall how ANN works. In other ways, neurons are basically a cell of the brain and a nervous system that are responsible for sending signals to the other cells. So we are very much concerned with the weights represents the interconnection strengths between the neurons. The activation function is a transfer function that is used to get the desired output for the problem designed. So the desired output is 0 or 1 in case of binary classifier, if we are using binary 1. So sigmoid is one of the type of activation function, could be used as the activation. So there is lot of activation function, linear regression, logistic regression, so many things are over here we will discuss in further. So moving forward, here are the different parameters, or you can say the types of the artificial neural networks. So we have divided according to the parameters. So according to the based on the connection pattern, it is divided into two types. ANN is divided into two types, feed forward and the recurrent. So what actually the feed forward is, in which graphs have no loops, and in RNN, that is recurrent, loop occurs because of the feedbacks. So these are the difference between the two types, that is based on the connection pattern. According to the pattern, these are forwarded and these are the loop based. Secondly, there are based on the parameter, that is the number of hidden layers. According to the hidden layers, there are two different types of ANN. First one is single layer, second one is multi-layer. Single layer is having one secret layer, and that is said to be single perceptron. Number two is multi-layer, that having the multiple secret layers, multiple layers perceptrons. So difference between these two are the number of the hidden layers. Number third types of ANN is based on the nature of the weights. Which kind of weight is over here? So two types are there, fixed and adaptive. Fixed is weights or fixed priority and not changed at all. They are already fixed weighted. We are not going to change any value over there. Then adapted are the updates that weights and changes during to the at the stage of training. So according to the next parameter, that is based on the memory unit, the type of AN is divided into again two types. Number one is static, number two is dynamic. Static is a memoryless unit, so it has no dependent on the memory. So the current output depends on the current input only. So it is said to be the feed forward, which was our first, and that is also that don't need any loop. Then dynamic is a memory unit. The output depends upon the current input as well as the current output. So that is the recurrent neural network. Moving forward to the next subtopic of ANN, that is the modes in perceptrons. Basically, this is one of the perceptrons which has a hidden layer and one input, then activation functions, then the output. It has two type of modes. Number one is training mode, number two is using mode. Let's discuss what is training mode. In the training mode, the neuron can be trained to fire or not fire, for particular input patterns. Depend on the patterns, it is the fired one or not. So the second one is using mode. In the using mode, when a dot input pattern is detected at the input, its associated output becomes the current output. You can see by the diagram, it is dependent on the gaming system, and using mode is very reliable. Moving to the forward to the slide, next slide, that is basically the main topic of our presentation, that is the layers of the artificial neural network. The work of our artificial neural network is not only depend upon only the inputs and the outputs, that is also concerned with the hidden layers. Now, what are the functions of those hidden layers? We will discuss. First of all, the input layers, as the name suggests, it accepts input in several different formats that provides the programmer at the initial point. The rubber second is hidden layer. What actually the hidden layers are? They basically presents in between the input and the output normally. It performs all the calculations to find hidden features and patterns of overall network. So what is the function of output? The input goes through a series of transformations using the hidden layer, which finally results in output that is conveyed using this layer, and a very much important one. The artificial neural network takes input and computes the weighted sum of the inputs and includes the bias. The computation is presented in the form of the transfer function. So basically, in short, we can say it determines ANN determines weighted total is passed as an input to an activation function to produce the output. So activation function choose whether a node should fire or not. The function of activation function is fire or not. Only those who are fired it make to the output layer. There are distinct activation functions available that can be applied upon the sort of the task we are performing. That depends upon the design of the performance or our desired inputs, our desired network. Moving forward to the next slide. This is one of the example of artificial neural network, that is basically a face recognition model. So at the left side, you can see the first stage, number of the inputs in the form of images has been given to the network, and it gives in the first layer, that is the input layer, and which shows you the pattern of local contrast in the left side. Afterward, it goes to the hidden layer, and hidden layers, a work of the hidden layer is here that it goes to the very much detail about their features. There can be the shapes in another example, but in this example it can be the face features. Face features means where the eye, the nose and the ear are in the picture. So the second, the third layer, that is the hidden layer 2, gives us a complete face after the processing, and we are going to able to recognize each person face at the stage of output layer. So in short, that input layer is said to be the pattern of local contrast, and the prediction of face is at the output layers. And this is one of the pattern recognition example of ANN. Now we will discuss about the learnings of the artificial neural networks. Basically, there are three types of the learning: the supervised learning, unsupervised learning, and reinforcement learning. So starting from its definition, the supervised learning is a method in which we teach the machine using labeled data. So basically to make or you can say to oversee or direct on certain activities, make sure it's correctly done, then machine learns under guidance. So at school, teacher guides us and taught us. Similarly, in machine learning, our machine learns feeding the label data and explicitly telling that this is the input and how this is the output must look. Teacher in this case is training data. Secondly, unsupervised learning. In unsupervised learning, the learning machine is trained on the unlabeled data without any guidance. So it means to act without anyone's supervision or without anybody's direction. So here the data is not labeled. There is no guide. Now here is the data having no any labels, and machine has to figure out set given it, and it has to find hidden patterns in order to make prediction about the output. An example of the unsupervised learning is adult like us, you and me. We don't need any guidance to help us in our daily activities. So we can see we have to figure out these things, our daily activities and all about us without any supervision, and the things with our own without any guidance. Number third is reinforcement. In reinforcement, the learning on agent interacts with its environment and producing action and discovers errors or rewards. So basically means to establish or encourage a pattern or behavior. Let's take an example that you are dropped isolated in island without knowing your destination and what to do. Initially you are panicked at that area, unsure what to do, where to go, what to eat, and how to eat, how to get food from, and how to live, and so on. But after a while you have to adopt. You must learn how to live on island, adopt to be changing climate, learn what to eat and what not to eat. Now you basically following hit and trial concept, because newly to the surrounding, here is the only way to learn is experience, and learn from your experience. This is what we say the reinforcement learning is. It is a learning method that is a you can say apparent an agent, which is basically you are treating you are stuck in the island that interacts with its environment, which is the island, and producing island and discover errors and rewards. And once the agent gets trained, gets ready to predict the new data present to it. So this is all about the reinforcement, third type of learning. Moving forward to the types of problems of all of these. Number one is supervised learning. By this diagram, you are able to distinguish that the known data is given to the machine, and known input is given to the machine. Here input are the apples, and these are apples, and it is given to the machine, and output is also known to the machine in supervised learning. So output is already given, input is already given. The work of machine is to only predict or map input and output, and that can recognize a new data that is said to be, basically it is a detection, or you can say recognition of new data, that is an apple. So it's an apple, it's a new response in supervised learning. Number second, unsupervised learning. Here are number of multiple inputs is given to you. They have different colors, different shapes, different features are there. Machine only knows the input, so you have to go through with the different algorithms. In unsupervised, they don't know what is apple and what is the mango, so they will make a cluster, different clusters, classify different categories according to their shapes, their color and the size, different parameters. So machine can say that I can see a pattern, according to those pattern it will give us the output, that those are the apples, the mango, and etc. Moving forward, the third type, that is the reinforcement. Now in reinforcement learning, the input is given. For example, here apple is an input, and it don't know, basically like as a robot or a child, they don't know what apple is until unless they will have experienced by their wrong selecting. So in this same sense, it is a mango. It is giving a response It's like a mango, so it gave us a wrong response. So wrong, it's the apple. So feedback come back to it, and it has learned about all over the procedure and noted that it is an apple, and it will go again and again recognize about the apple and input is apple, and it recognized by reinforcing by its own experienced by the agent, that is a reinforcement response output. Now the verses, or you can say the difference between two types, that are supervised and unsupervised. In short, you can say supervised is labeled data. They are direct feedback. They predict outputs. So they are already known outputs in supervised. Number second is unsupervised. They are not labeled. The machine don't know about the data. It has to recognize, for example, there are number of the kids or number of the dogs. It has to label it and recognize it by the different parameters and the shapes and its features. It has no feedbacks, find hidden structure in the data. According to the data and the structure, it has to recognize and give the output to the machine. Moving forward to the types of the problems comes over in the different learnings. First of all is the supervised learning. Supervised learning has the regression. What actually the regression is? Regression is said to be the type of supervised learning and algorithm, and it is supervised machine learning technique that is used to predict continuous values. Continuous quantities can be predicted by the regression process. So we can say that in regression, the prediction analyze used to be continuous quantity, and second one is the classification, and that is to predict a label or class. Or for example, we are taking here an email example, and they have to classify either it is input, output, or spam folders. Different groups are over there. They are not labeled, and they are said to be for the regression. They have a continuous quantity, and example for the continuous quantity are the weight of the persons. They are infinite, and you can say the 180, one of the person has 180 or 180.1, 180.110. So infinite number of possibilities are there in the regression process. Here comes the second type, unsupervised learning. And unsupervised learning, the association is here. The association is a rule learning, is a kind of unsupervised learning technique that tests for the reliance of one data element on another data element and designed appropriate so that it can be more cost effective. It tries to discover some interesting relation or association between the variables of the data sets. So you can say the discovering pattern and the data is said to be the association problem, finding co-occurrence and so on. So example for that is that a relationship between the bread and the jam. People tend to buy bread, also buy a jam. So figure co-occurrence from these similarities to each other, the items similar, so that is said to be the association. Number second type of unsupervised is clustering. What actually the clustering is, it is a process of grouping similar entities together. So these entities are should be similar, and the goal of this unsupervised machine learning is to find similarities in the data point and group similar data point together. So clustering are the target marketing list of the customer, or based on the similarity, different categories are over there based on the interest in the intent. And example for the clustering is a credit card fraud or tracking of unusual activities. Here comes the third one, that is reinforcement learning. Key difference is that input is that itself depend on actions taken into the reinforcement. And for example, in robotics, after performing certain actions, he come to know depend upon whether choosing to move right or left or forward or backward. So he come to know what is the right decision. robot will know with the experiences and the environment. In this case, robot is the agent and the surrounding is the environment. For each action, it takes a reward or might be receive a punishment. So after it performs some actions, it will find out more about the world. So that is for the reinforcement problem. Now here comes the next slide for the learning types of data. Supervised learning has already given the input, and that is labeled data, and input and output is given to the machine. It has to only map the decision according to their algorithms. Either it is a cat, for example here, either it is a cat or a dog given over here. So simply it is a labeled data. In unsupervised it is unlabeled. You have to recognize either which one is the dog, recognize according to their algorithms. With the help of the algorithm, machine has to recognize dog and the cat. Then in reinforcement, again the same, the agent has to do actions according to their environment to learn more about the perfect or correct decision, and this way a robot has to go through with the reward or the punishment and repeat. It will repeat again and again. So in short, no predefined data is given to the reinforcement learning. Moving forward to the training, how they are trained. Basically, in supervised learning, there are external supervision. As we have talked about the teacher is external supervisor in supervised learning. It is already known about the output and the input in supervised learning. So teacher is one of the external supervision in our training process, and it is well defined both, and it is labeled only. This is to map the input and output, and once it's well trained, it teaches or guide over the act like, and once it is a well trained, tested using new data. So it has to just give the new data. Second one, unsupervised learning. In unsupervised learning, there is no supervision. It has to go through with its own. It don't know about the output. Training phase is big, so no supervision. Machine only gives input. Output is on its own in unsupervised learning. Number third is reinforcement learning, and it has no supervision. Either it doesn't know anything like a child. It will go through and learn with the experiences and the activities. So no predefined data. Training and testing phase has to go with its own experiences. Okay, so moving forward for the aim of these three. Aim of these three, number one is supervised learning. Aim is for cost outcomes. It is mainly designed for the outcomes. And number second, unsupervised learning. Discover underlying patterns according to the shapes, patterns, and their features. It have to identify or recognize its output. And reinforcement learning, it has to learn more about the world by their experiences, to predict more and more according to their atmosphere. Like a child don't know about anything. It will slowly with the help of experiences know about each and everything. So moving forward to the next, that is the approaches, and here are some differences between these three. So in short, that unsupervised learning, non-labeled training data. Supervised learning, the machine learns from the training data that is labeled. It is already labeled. Now reinforcement, it has to learn both input output by its own. The approach of supervised learning is that it has to map labeled input and to the known output. It is already mapped over there at the training, an algorithm, and known output is given into the supervised learning. On the other hand, at the unsupervised learning, that understands pattern and discover the outputs, unlabeled data is given to the machine. It has to explore the patterns, trends, and features with the help of algorithms to predict a particular output. Now here comes at the most right side, that is a reinforcement learning. They totally follow trial and error method, and it has go through with the experiences, and the approach for the reinforcement is to trial and error method. Next slide, that is the output feedback. Now supervised learning is the direct feedback method. It is a known output is coming back to the labeled input, and number two, unsupervised learning, unlabeled input is there. And in the third, that is environment is rewarded or punished, so it will go again and again. Reward system is there, so reinforcement learning has the reward system. Moving forward for the approaches of your popular algorithms. The popular algorithms are used for the supervised learning are here: linear regression, logistic regression, SVM, support vector machine, k nearest neighbor, random forest. Then here comes the unsupervised learning. K means a priori, C means comes in the unsupervised learning. Reinforcement learning algorithms are the Q-learning and so on. Here are some applications used for these three learning methods. Supervised learning has a risk evaluation process, forest scales, and unsupervised learning is a recommendation system. What actually the recommendation system is, once we are going to buy online, there are some recommendations coming over there. Then anomaly detection comes in the unsupervised learning. So anomaly detection is identifying data points in data that don't fit the normal pattern. It can be useful to solve many problems, including fraud detection, medical diagnostic, etc., and so on. So reinforcement learning itself, car driving by their own. Then the gaming system. Moving forward to the advantages of artificial neural network. Now here are the some of the advantages of artificial neural networks. Number one is parallel processing capability. Artificial neural network have a numerical value that can perform more than one task simultaneously. Number two is storing data onto the entire network. Data that is used in traditionally programming is stored on the whole network, not on a database. So that disappearance of the couple of the pieces of the data in one place doesn't prevent the network from working. So capability to work with incomplete knowledge is the third advantage of ANN. After ANN training, the information may produce output even with inadequate data. The loss of the performance here relies upon the significance of missing data. So that is the capable to work with the incomplete information or knowledge, you can say. Number fourth one advantage of ANN is having a memory distribution. So in ANN is to be able to adopt, it is important to determine the example and to encourage the network according to the desired output by demonstrating these examples to the network. The success of the network is directly proportional to the chosen instance, and these events can't appear into the network and in its specs, so it can produce false output. That's why having a memory distribution. The last one advantage is having fault tolerance. So extortion of one or more cells of ANN does not prohibit it from the generating output, and this feature makes the network fault tolerance. These are the all you can say the advantages of artificial neural network. Moving forward to the disadvantages of artificial neural network, and starting from the first one, that is assurance of proper network structure. There is no particular guidance for determining the structure basically of the ANN. The appropriate network structure is already accomplished through experiences, trials, and errors. So unrecognized behavior of the network is one of the disadvantage of ANN. It is the most significant ensure that ANN produce a testing solution. It does not provide insight concerning why and how. It decreases trust on network, so that's why that is unrecognized behavior in our network. So third one is a hardware dependence. It depends on the hardware, so that needs processor with parallel processing power as per their structure. Therefore, the realization of the equipment is dependent on the hardware. So the fourth one is the difficulty of showing the issue of the network. It can work with the numerical data. Patterns must be converted into the numerical values before being introduced to our network. So presentation mechanism is to resolve here directly impact the performance of these network, and it relies on the user's ability how it go to these issues. The last disadvantage of the network ANN is the duration of the neural network is unknown, and it doesn't know, and the network is reduced to a specific value of error, and this is the value does not give us the optimum result. So that's why it is the disadvantage of the neural network. Now we will discuss about the activation functions that comes in our artificial neural networks. There are the number of the activation functions in ANN. So activation function is one of the important parameter to discuss over here. An activation function is a function basically used in artificial neural networks which output a small value for small inputs and a large value if its input exceeds a threshold. If the input are large enough, the activation function fires. Otherwise, it does not. It doesn't do nothing. In other words, the activation function is like a gate that checks that an incoming value is greater than the critical number or not. So basically it is very important to know about the different types of the activation functions. So here are the activation functions useful because they add non-linearities into the complete neural networks that basically allows the neural networks to learn powerful operations. If the activation functions were to be removed from a feed-forward neural network, the entire network would be refactored. So the simple linear operation or matrix transformation on its input, and it would no longer be capable for performing complex tasks and designing such as the image recognition and any type of designing recognition over there. So well, non-activation functions are there, so we can have different type of the activation functions in front of you. So most commonly used activation functions are these three: the sigmoid, the tangent edge, then the ReLU, rectified linear unit, and these are the three most important one. ReLU is mostly used in for the deep learning, and we can see here are the binary learnings. These three number one by one we will discuss. Sigmoid is number one, and number two is tangent, ReLU, and how they are designed, how they are differentiated, which one we have to select for our own uh, designing of networks. So first of all, we will discuss about the sigmoid activation function. In sigmoid activation function, we will see over here by the diagram that is very clear the key functions of the key features of the sigmoid is that this is also said to be logistic function and used in the logistic regression models. Then the sigmoid function has an S-shaped graph according to these S-shaped type graph, and it is clearly shown that it is a nonlinear by their S shape, and the sigmoid function converts its input into the probability value, and that is between 0 to 1 obvious. So it converts large negative value towards 0 and large positive value towards 1. It returns 0.5 for the input 0, and the value 0.5 is known as the threshold value, which can decide that a given input belongs to what type of two classes are there. How we will use these type of sigmoid activation function? Basically, we can see that in the earlier days, the sigmoid function was used as activation function for the hidden layers, for the MLPs, the CNN and the RNN. However, the sigmoid function is still used in RNN. Currently, we don't usually use this sigmoid function for the hidden layer for CNN. Instead, we use ReLU or leaky ReLU. The sigmoid function must be used in the output layer when we build a primary classifier in which the output is interpreted as a class label depending on the probability value input returned by the function. So the binary classifiers are there to use the sigmoid activation functions. So moving forward to the drawbacks about these sigmoid, we don't usually use the sigmoid function in the hidden layers because of the following parameters, and those parameters are that it has the vanishing gradient problem. This is known as the saturation of the gradients. So the sigmoid function has low coverage as well, and it also has the output are not zero centered. Therefore, it makes the optimization process harder to understand, and this function is computationally expensive as compared to other, and that is very much difficult to do. So moving forward to the next activation function, that is a tangent activation function, and by their shape you can also see here that it has the non-linearity in the graph. So discussing the tangent activation function, the main key feature of the tangent is that that always ranges between -1 to the +1. Like sigmoid, it was S-shaped. This is also a nonlinear function, as I've already told you. One advantage of using tangent edge function over the sigmoid function is that the tangent edge function is zero-centered. This makes the optimization process much easier as compared to sigmoid. So tangent edge function has a steeper gradient than the sigmoid function. How we will use, we can use these type of activation function in CNN, RNN. However, it is also used still in RNN. Currently, we don't use tangent edge function for the hidden layers, but we instead we prefer for the ReLU functions and leaky ReLU functions. We never use a tangent function in the output layers. So drawbacks for the tangent edge is that we can say that the tangent function has the vanishing gradient problem, like is same for that sigmoid one. Now the third type that is we have to discuss is ReLU activation function. Nowadays it is used for the most deep learning process. Deep learning neural networks using these type of ReLU functions, and it is said to be the most important activation function. The main key features for the ReLU are that they are great alternative to both sigmoid and the tangent, and it is inventing ReLU is one of the most important breakthrough made in deep learning. This function does not have the vanishing gradient problem. This function is said to be the computationally inexpensive. It considered that the coverage of ReLU is 6 times faster than the sigmoid and the tangent edge functions. If the input value is 0 or greater than 0, the ReLU function outputs the input as it is. If the input is less than 0, then ReLU function outputs the value 0. The ReLU function is made up of two linear components because of the ReLU functions. It is a piecewise linear functions. In fact, the ReLU function is a non-linear function. The output of the ReLU function can range from 0 to positive infinity. The coverage of the faster than the sigmoid. So it is because the ReLU function has a fixed derivative slope or for one linear component, or and you can say the zero derivative for the other linear component. Therefore, the learning process is much faster in our ReLU. So calculations can be performed much faster as well in our ReLU because no exponential term is used that includes in the other activation functions in sigmoid and tangent. So how and where we can use these type of ReLUs? So basically we are using nowadays in CNN and neural networks, and we don't usually use ReLU functions in the hidden layers. Instead we use the sigmoid, or you can say the function. We never use ReLU function in the output layer. The drawback for the ReLU is that the main drawback that it has a dying ReLU problem. The value of the positive side can go very high, so that may lead to a computational issue during the training process or training duration. So these are the main basic activation functions have discussed over here. So now here comes the representation of the powers. If we will increase the hidden layers, hidden neurons inside any recognition process, these are the differentiation between the representation power. So 3 hidden layer look like this. 6 hidden layer has more clarity, and the third one 21 has the neural networks are powerful. So exactly uh, why with this computing power there was a renewed insert into the them. With great power comes great outfitting. Now what actually the outfitting is? Outfitting is an undesirable machine learning behavior that occurs when the machine learning model gives accurate prediction for training data but not for new data. So this is basically about the uh, representation of uh, power of the. Let's discuss about the network architecture of ANN. These are basically connection patterns. Connection patterns, according to the connection patterns, the two types are there: feed forward and recurrent. In feed forward, there are three basic types: single layer perceptrons, multi-layer perceptrons, radial basis perceptrons. So RBF we can say in short. So in recurrent, the competitive networks are there, coordinates are there, Hopfield and ART models comes in our recurrent of the connection patterns. According to the connection patterns, these are the different types of network architecture. Moving forward with the network types, perceptrons model in the neural networks is the one architecture type. Then I have already told you about the RBF neural network, multi-layer perceptron neural network, then recurrent neural network, long short memory neural networks are also there, Hopfield networks are there, Boltzmann machine, then convolutional, then model modular neural network, then physical neural networks are there. So by this kind of diagram, we are able to discuss over with the one by one different uh, categories of the neural networks. So first one is a perceptron model. Neural network is having two input units and one output unit with no hidden layers. These are also known as single layer perceptron. So that's why it is said to be single layer perceptron. Number two is your RBF, radial basis function. These networks are similar to the feed forward neural networks, especially except the radial basis function is used as these neurons activation function. Number third is the multi-layer perceptrons. According to the diagram, you can see here are the multi-layers. So these networks use more than one hidden layer of the neurons, unlike single layer. So these are known as the deep feed forward neural networks. And next one is recurrent. Now how you can say these are recurrent? In recurrent, in the hidden layer neuron have self connections. It possesses memory at any instance, the hidden layer neuron receives activation from the lower layer and its previous activation value. So it is said to be the recurrent neural network. Next is LSTM, long short term memory neural network. What actually it is, in which we can say memory cell is incorporated into the hidden layer of the neurons, that is said to be LSTM network. Then hop-fied networks, a fully connected network of neuron in which each neuron is connected to every other neuron. So the network is trained with the present pattern by setting a value of the neurons and to be desired pattern. Then it's said to be the hop-fied neural network, and its weights are computed. The weights are not changed. Once trained for one or more patterns, the network will coverage to the learned patterns. It is different from other neural network. In Boltzmann machine learning network, the networks are similar to the Hopfied, like you can see by these two diagrams. Then, except some neurons are inputs while others are hidden in nature. The weight are initialized randomly and learn through the back propagation. So here comes the CNN. CNN is the class of neural networks you already know about, that is specialized in processing, and you can see by the diagram that data that it has a grid-like topology, such as image. A digital image is binary representation of visual data in CNN. Then here comes the modular neural network. It is a combined structure of the different type of you can say like multi-layer perceptrons, hop-fied network, recurrent network, etc., which is incorporate such as a single module into the network to perform independent subtask of whole complete network. Then here comes the physical neural network. This is one of the type of artificial neural network, and electrically adjustable resistance material that is used to emulate synapse instead of software simulation performance into the natural, or you can say the different type of neural networks. So this is all about the different types of artificial neural networks are there. Now we will discuss about the artificial neural network in pattern recognition, how it is generally relate in the pattern recognition. We can see by this diagram that pattern recognition in artificial neural network is that is basically uh, operation, that is at the left side the input pattern is given to us, that is the data acquisition and pre-processing firstly, and secondly at the right side the decision making is over you, that is complete data representation is there. In between there is a neural network, and that is adjustable according to their weights and the biases, and summation is there. There are the activation functions. By the diagram you can see the activation function, biases, the output is given in our neural networks. So in this way and pattern recognition is study how machines can observe the environment, learn to distinguish pattern of the interest from their background, and make sound and that are the reasonable decision about the patterns categories basically. So examples are you can say the applications we can use of the pattern recognition in artificial neural networks are the fingerprint images and handwritten word, and you can say human face or a speech signal. So given an input pattern, its recognition involves the some of the tasks, and those tasks can be the supervised classification. So we can, given the input pattern is known as the member of the predefined class. Number two is unsupervised classification. That are assigned basically pattern is to be you can say the known class. So the recognition problem here is essentially a classification or categorized task. The design for the pattern recognition system usually involves the following task, or you can say in the aspects. So first one is the data acquisition, as it is shown to you in front of you, that is said to be the pre-processing step. Number two is the data representation, that represents you about the data. decision making, how typically the decision making is involved, then that approaches for the pattern recognition and patterns are there, and temple matching is there, statistical is there, then synthetic matching is also involved in the pattern recognition. So in neural network architecture used for the pattern recognition, which kind of neural network architectures are mostly used in pattern recognition are: first one is the multi-layer perceptrons, number two is the coherence SOM, self-organizing map, then RBF network are used for the pattern recognition in artificial neural networks. So that's all for about these artificial neural networks. Thank you so much. Allah Hafiz.